Hello, my name is Keshwani. It's K-E-S-H-W-A-N-R, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 282. And today is our lesson number 100. Please turn to page 282. The very first problem that you see on the page, it has a picture there, so I'm going to try to redraw the picture. Well, I'm not going to try to redraw it. I'm going to redraw the bloody thing. So we are given a triangle here, ABC, we are told, is a right angle triangle, ABC. And on top of it, we have another triangle, which is also a right angle triangle. We are told that this is also a right angle triangle, and that is ABD. The question simply is that all? That's it. The question simply is the area of triangle ABC equal to the area of triangle DBA? So we have two triangles here. We have a triangle ABC. Is the area of this triangle same as the area of DBA or ADB, whatever you like? That's all it is. A very simple, very straightforward question. Let's see what they give us. In the first statement, they're telling us that AC squared is equal to 2 times AD squared. Now listen, we're going to start the solution here. I'm going to introduce some terminology just to keep track of things. I'm talking about triangle ABC. Triangle ABC. In the triangle ABC, this is the base. C to B is base, so I'm going to call it B. B for the base. And A to C is the height. I'm going to call it H for the height. Okay? AC, A to C is the height. So we are told that H squared equals 2 times AD squared. Let's see what AD actually works out to be. Let's see what AD actually works out to be. Let's call this thing A to D. Let's call it X. So we are told that H squared equals 2 times X squared. A to D, I'm calling it X. And the question simply is the area equal to each other? Let's solve this thing for X. So X squared equals H squared over 2, which means X equals H over root 2. I'm going to put it here. H over root 2. So far so good. Since we have gotten the information out of the first statement there, I'm going to erase this thing because I need the room. So that's what this gives us. This statement, AC squared equals 2 times AD squared, gives us this part. It tells us that this side, A to D, equals H over root 2. One more time, how do we get it? I call it X. Therefore, H squared equals 2 times X squared, because A to D is X. 2 times X squared, when you solve for it, X comes out to be H over root 2. That's all we get out of it. Now let's see what they're giving. The question now is the area of triangle ABC, is it equal to the area of the triangle DBA? It's a question mark. It's a question mark. Are those two areas equal? Let's just see what happens. Let's just see what happens. What condition will we? What would we have to know? What condition we will have to fulfill in order for these two areas to be equal to each other? So area of triangle ABC, the height is H, the base is B. Therefore, it is 1/2 base times height. And the area of the triangle DBA has the base is this. The base of DBA. This is our base. And the height of the DBA is AB. 1/2 base times height. 1/2. The base is this part right here. That's what we're calling it base here. And the height of the triangle, so that's h over √2. The height is this part, A to B, that's our height, AB. And how much does AB equal to? Because of the fact that this is B and this is h, this comes out to be square root of B squared plus h squared from simple Pythagorean theorem. Okay, stay with me in that story. So that's what I'm going to put here. Square root of B squared plus h squared. So far so good. And here we have 1/2 base times height. Here we have 1/2 this part. Therefore, I'm looking for my red pen here. Therefore, this 1/2 drops out. I see an h here. I see an h here. It drops out. Multiply both sides by √2. Multiply both sides by √2, and we end up with √2 times b equals, this √2 is going to drop out. If you multiply this side by √2 and if you multiply this side by √2, this √2 is going to drop out, and we end up with b squared plus h squared. Let's take the square of both sides. If you take the square of both sides, we end up with 2 times b squared equals b squared plus h squared. What happens? Subtract b squared from both sides. If we subtract b squared from both sides, we end up with b squared equals h squared, which implies that b equals h. Now remember, this is not a fact. This is not something we know. This is a question mark. Is it true? Is it true? Is it true? Is it true? Is it valid? Is it true? If somehow we can answer this question, is the base of this triangle equal to the height of the triangle? In other words, the question is this triangle ABC, is triangle ABC an isosceles triangle? That's the question we have to answer. If B is equal to H, this side has to be equal to this side. And if that were true, if base is equal to H, then we can work backwards. We can take all the steps in reverse, and what we'll find is that at the end, area of the triangle ABC will turn out to be same as the area of the triangle DBA. Is there any way we can answer this question? Is base equal to the height? The answer is no. Based on what we know so far in the first statement, the answer is no. The first statement by itself is not enough. The first statement by itself is not enough. AD, BCE. Since the first statement by itself is not enough, the answer cannot be A or D. Somehow, some way, we have to figure out if the base is equal to height. In other words, somehow, somewhere we have to find out if this is an isosceles triangle ABC. If they tell us that part, then we are home free. Let's see what they tell us in the second statement. I'm not going to erase any of this thing. I want to leave everything here. Listen, we are done with all this work here. This is what we're trying to establish here. We are done with all the work here, so I'm going to erase this part. We are done with all of this thing. We are done with the picture. Okay? And I'm going to erase this part also. Leave it. I'm trying to save room. I'm trying to save room here so that I have, voila. The second statement, what does second statement tell us? Second statement tells us, what do you know? Triangle ABC is an isosceles triangle. Triangle ABC is an isosceles triangle. In other words, what they're telling us is that the B equals H. In the diagram that I just erased, B equals H. Again, that by itself, you must pay attention, okay? That information by itself is not enough for us to be enabled it's not enough to enable us to answer the question, is the area of the triangle ABC equal to the area of the triangle DBA? That by itself is not enough. So second statement by itself is no good, which means we had AD, BCE, since the first statement by itself was not sufficient, we needed to know this part. Since the first statement did not provide us this information, therefore the answer was not A or D. Second statement by itself is also not sufficient. But if you put them together, it tells us, the second statement clearly tells us exactly what we needed to know, that the base equals height. Therefore, if you put them together, we can work backwards, and area of the triangle ABC would be equal to the area of the triangle DBA. That's all. Therefore, together, they are okay. The answer is C. Together, they are okay. The answer is C. What I'm going to do now is to very quickly actually show you that the area of the two triangles are in fact equal. We don't need to do that for the exam. As far as the exam is concerned, we are done. The answer is C. But let's do them very quickly, okay? Together, they are okay. I'm going to do it right here. The triangle ABC equals 1/2 base times height. But because the base and the height are equal, so it's 1/2 base squared or 1/2 height squared. It's the same thing because base equals height from the second statement. This comes from the second statement. Leave it at that. The triangle ADB equals 1/2 base, which is height over √2, and this came from the first statement. This came from this part, and this part came from the second statement. This part, h over √2, if you remember, came from the first statement. In the first statement, the relationship that they gave us, which boiled down to the fact that the base of the second triangle ADB was h over √2, and the height we found out was b squared plus h squared. My diagram is gone on the picture, so I cannot actually point to it. Refer to your picture and you will see that the height was the hypotenuse. The height of the triangle, listen very carefully, the height of the triangle DBA was the hypotenuse of the triangle ABC, which was this part, b squared plus h squared square root of it. Let's see what we can do here. Since b squared equals h squared, this is same as 2 times h squared, which of course is same as 1/2 h over √2 over √2 times h. √2 times h, and what happens? This √2 cancels out with this √2, and we end up with 1/2 h squared. Voila, 1/2 h squared, which is exactly what we have here. So the areas of the two triangles are in fact equal if the bottom triangle happens to be an isosceles triangle, and if the relationship that they gave us in the first statement holds. Putting the two conditions together, we can answer the question. Yes, the areas of the two triangles are in fact equal. That's all. That's it, we're done. I'm not going to start another question. I'll see you tomorrow, okay? Bye now.